Hello everyone, welcome back to Comp 232. Today we'll continue with our linked list structure. We want to finish up with all the functions, the different functions of the linked list data structure and its implementation in C. We'll be providing you with a file that has all the code in it, in which you, like I did in the queues. I hope you all respond for the queues homework. You should check the Word file that I have put on Moodle. At the end of that file, you have an assignment to do, okay? And you have to submit it to me either by email or on Moodle. Okay, make sure that the subject is Comp 232, assignment number 2, let's say, okay, or assignment queues. All right. Now, concerning the linked list, let's continue with our work. Again, I'm going to give you a Word file of all the code that I used here so that you can plug it in and try it in your on your compilers. So now I got to a point we saw last time how to add an element in the linked list. Let's continue today with how to actually remove an element from a linked list. And as I told you, we can add and remove at any position in the linked list. Okay, so unlike queues and stacks, where you can only add from the top or add from the back like in queues, in linked list you can add and remove from anywhere in the linked list. Okay, so now to add at a kth position, to remove an element from the kth position, so this was here, what should you do? As you can see, we have to set the pointer to be pointing at the node that you want to remove. So we set a pointer variable pointing equal to this pointer, which is pointing to the node that we want to remove, okay? And then set this pointer equal to the node after it. In this case, when you set the pointer equal to this address, which is the pointer pointing to the node after it, so I want to set this pointer equal to this pointer. So the node before I delete it, I take the address from it and give it to the node before it. And then the node before it, node 1, this one will be pointing to node 3. And what I do is that I free the memory that was taken by node 2. Let's see its implementation by C in C. So as I said, so this pointer should be pointing to node 3. So this pointer is equal to this point. And now node 1 is pointing to node 3, and now node 2 is removed. Now node 3 will become node 2, and this one is removed. So how to do it in C? Remove node. If you need it, you can return its pointer here. If you don't need it, we're removing it, we're deleting it, then we will delete it and free the memory. It's taking it takes two arguments. The first one is actually a pointer to node, which is your your linked list is represented by a pointer to the first item, because the first item contains the pointer to the next item, and it contains the number of elements in the linked list. So it's sufficient for a linked list, like in stacks and queues, only to have the pointer to the first element, because knowing the pointer of the first element, you can get to any element in the structure. The second argument is position. So that's the position. I want to remove the element at this position. So what do? We set the variable pointer equal to p first element, and as we said before, this pointer is going to move in the linked list until it points to the element I want to remove. So we continue incrementing the pointer. not incrementing because they're not actually sequential in memory, but making the pointer from one node, moving the pointer from one node to the other using this loop. So I is only to trigger where are we. But how are we moving in the linked list using this pointer equal pointer dot p next node until I is less than position, which means that until we are at the element that's pointing to the element at this position. So pointer will stop when it's pointing at, okay, the element we want to remove. So this for loop will make sure that PTR's value is equal to the address, okay, of the element we want to remove. Is this clear? In our case, this was, let's say, node 3. So PTR is pointing to node 3. It will move through the pointer until it points to node 3 because position was equal to 3. Okay, so the first value is 1 plus plus it will become 2. Now this is the value that's inside the second node, okay, and the value inside the next node is actually pointing to node 3. So now ptemp node, we're using a temporary node is equal to pointer dot p next node. All right, so we're saving the pointer in p temporary node because p next node is now the point. Where is p next node? This is in node 2. So this is present in node 2. So this is the address, the pointer of the pointer part of node 2. So now the pointer in node 2, okay, I want it to be equal to ptr dot next node. This is me. What is pointing to? This is node 3 dot next node. So what is node 3 dot next node? This is what this is. So this is ptr. No, this is 2. So this is node 2. Okay, ptr dot p next node, ptr dot p next node. This is the address of node 2, right? We all agreed this is the address of node, the address part, the pointer part of node 2, the pointer part of node 2, the pointer part of node 2. Okay, so the pointer part of node 2, yes, which is pointing to 3, correct. So 3 dot p next node. Okay, you understand it? So this is the pointer in node 2, which is pointing to 3. We said it here again. The pointer in node 2. I don't want to go back, because if I go back, the pen will be deleted. So this is node 2. This is node 3. And this is node 4. So the pointer part, so this is node 2, node 3, and node 4. The pointer part here of node 2 is this one, ptr dot p next node. This is this one, okay? ptr dot p next node, ptr dot p next node. This is the pointer of node 2, which is pointing to 3. I want to set it equal to, pay attention, I want to set it to ptr dot p next node, which means this node dot p next node. So I want to set it equal to this pointer, because ptr dot p next node, okay, this is this pointer to 3. If I did this pointer dot p next node, that's this value. Okay, so this is the pointer pointing to 4 actually. So this is the one pointing to 4. You see how it is? Yeah, ptr dot p next node, this one over here, but this is the pointer to this element. So if I set this pointer to this element arrow, which is as if dot, yani p next node, so this is this value here, the pointer to 4. What am I doing to it? I'm putting this value where? In here. Because what did I say? ptr dot p next node, that's the pointer in 2, set it equal to this pointer over here. Okay, so now 2 is pointing to 4. So we have skipped node 3. We have removed node 3. Okay, so now 2. Why is pointing to 4? Because I put its pointer value equal to the pointer value of node 3, which is pointing to 4. So now node 2 is pointing to 4, and in this case we have skipped node 3, or we have removed node 3, and the reason why I put it in temporary here, because I want to free it. We freed the temporary node which had the pointer to 3. Okay, if I didn't save it in temporary node, it will have disappeared because I updated it to point to 4. So what happened to it? I saved it in a temporary node to be able to free it. And now 3 is totally removed, and this will become 3, and the number of nodes is updated in this one, number minus minus, which is the number element in the first node, the number part of the first node, which is the number of elements in the linked list. Okay, removing an element from the beginning of the list. Okay, we're going to call it remove from beginning, and all we need is the pointer to first node, which is your linked list, because having this, that's having the pointer to the first node, we can get to any node in the linked list. And we want to remove from the beginning, so we don't have to specify the position. So what did we do? We said remove node. So remove from beginning, called remove node. The one we implemented was called remove node. It takes 2 arguments, so I'll give it p first node, and the position is actually definitely 1. So it will remove the node at 1, which is this one, the first node. Okay, that's it. All you have to do is do that. Removing from the end of the list, again, this function is called remove from end. Okay, and it's going to call remove node. But what is the position of the last element? The position of the last element is actually, in this case, for example, 4, and 4 is actually the number stored here, which contains, we said that the first element in the linked list contains the number, or the count, the number of nodes in the list. In this case, the number, we have 4 nodes, so here you have 4, and when we remove from the last node, we put p first node dot number, which is going to give me 4, which is the position of the last element in the queue, in the linked list. Now, changing an element value at the kth position. So we just want to get to the kth position from the first element. Okay, we want to get to this position and change its number value to a new value. It's not returning anything. Okay, so how do we do that? We initialize pointer to be pointing the first node, and then we move with the for loop the same way we did all the functions in linked list so far, is that we move to it until ptr is pointing to the element at this position. So ptr is pointing to it. Now that it's pointing to it, okay, ptr equal ptr.pnext node, we're going to have this dot number is equal to new value. Okay, so I'm going to change the number to the new value. All right, now changing an element value at the beginning of the list the same way we did there. Okay, but now we're going to set it to be equal to 1 because it's at position 1. Now this one is at position, what are we doing now? Changing an element value at the end of the list. Okay, so this should be at the position p first node dot number, which is the last item in the list. Okay. Is this clear? So we actually did all the functions. Please, if anybody go back, and if anybody has any question, don't hesitate to ask either by email or by commenting on the video. Okay, and I will set another we'll do another video and answer all your questions. So please don't hesitate to ask if there's something that you did not understand. All right. Okay, very simple. So changing the value, I will repeat again. So changing the value in a position, we go that the pointer point to this value, okay, to this item, and then this item pointed to by the pointer dot number, we change it to the new value. So now the position will change once it will become 1, and if it's at the beginning, and it will be the end number, the number of nodes if it's the last element. It's very simple. Now how to print all the elements of the list. Okay, so how to print all the elements of the list. So to do that, we only need pointer to first node. Okay, and this is just for formatting. What we said that the number of elements in the list is star p first node, star p first node dot number. Okay, or we could have said pointer, we used star pointer, so we get back to the variable, and that's why I can put dot. Otherwise, if I used p first node only, I would have put actually an arrow. Okay, but we said star p first node. Now I can put node, I can put not dot and number. Okay, so this is the number of elements in the list. Okay, and now node star ptr equal p first node dot p next node. We're starting with the first. Now it's pointing to actually node 1. Okay, so ptr now is pointing to node 1. Okay, so if I print ptr in decimal and in hexadecimal and ptr dot number, this will give me the number in node 1 and the pointers to the number in node 1 to the node to node 1. So this pointer to node 1, pointer to node 1, same pointer, and the number in node 1, and then we go ptr equal ptr dot p next node to go. Now we're pointing at node 2, etc. until the last item. We didn't say until pointer is not equal to null, but not so we stop at the pointer when it becomes actually equal to null. Okay, so when ptr is not pointing to anything, that's the end. So we'll stop when we reach the last element, and that pointer will be pointing to null. Okay, so this one actually prints all the elements in the loop. Again, on the Word file, I have all this code. I want from you to write it down and see the output. This is only for formatting, as we said before. Okay, just copy and paste it and run the main. I want you to look at the output, and I want you to actually screenshot the output and show me that you are actually working and looking at the output of this code, all right, by sending it to me. And that's how I make sure that you guys are actually interacting with me and taking the code and putting it in your Visual Studio and running it. Now, displaying an element in the kth position, we have already did we actually already do this as a function? No, we're doing it now as a function. Okay, so we didn't do it as a function. We are doing it now as a function. Display node, it will display to me. So this is printing all elements. This one here is displaying the value of an element at the kth position. We just want to see, okay, the element at the kth position, at this position, that is, position is k in this case. So what do we need to do? We need to have the pointer move from the first item, from pointing to the first node in the linked list. I want it to move until it points to position, and that's when I change the value inside. No, I display the value inside it. Okay. So the element at this position, the one that I pass to the function, okay, is, so what I do, I put a pointer ptr to be equal to p first node, and then I'm going to move it again. This for loop moves the pointer until it's pointing to the element in position, such that a ptr dot number, okay, will give me actually, because it's pointing to the element, so this one will give me the number inside this element. All right. And now this is a main function, okay, that will actually, I want you to write it down in order to try all your functions that we said that we were talking, we introduced in this lecture. So first we have to create a new node using the create a new node, all right, and give it 0. Okay, this is going to be the number of elements in your linked list is 0, and this is a pointer to the first node. Okay. Now we're going to use a do while loop to create the body of the program that will include all the actions that you can do. Okay, so we're going to have you select one, have the user select one of these options, which represent the functions that we did. Okay, and we're going to take in his choice, and then we're going to switch choice and have all the choices inside here. You have to build up your code. Okay, so while choice is not equal to 12, when it becomes equal to 12, then it will exit. Okay, so case 1, okay, what was add an element at the get position, and that's how I start. I'm going to start by adding elements to the linked list. Okay, before I display them, before I change with them, I have to first add elements. So please enter the new value. I input the number. I ask for the position. Okay, the position should be 1 because this is the first element. If you didn't put 1, it will not work because I have to make sure that position is not greater than. So if position is greater than p first number plus 1, so if it's greater, in my case, we started the linked list with 0 elements. So you should put position 1 because you should add the first element at 1. If you put 2 here, then it will check is 2 greater than p first node dot number, which is 0. When we start, the number of elements is 0 plus 1, which is 1. Is 2 greater than 1? Yes, then you cannot add an element. All right, so it has to be, okay, it has to be equal to position. The position should be equal to p first node dot number, okay, plus 1, which is at the first position. So else, add node, p first node, create node, new number, and position. So we're calling function add number. We already have implemented add node. So add node, p first node, this is the pointer to the linked list. Create a new node, this function returns the pointer to the new node that has new number in it. And this is the position at which I want to add it. And in my case, this should be 1 because it's the first position, and then I can select case 1 again and add at the second position, the third position, and so on. Please try it. It's very straightforward. If you don't give me, if you don't send me your feedback through actually screenshotting of the run of this program, then we see what to do. So you have to actually write it down and see its run. So in case 2, we can, if you select case 2, you can add an element at the beginning of the linked list. So case 1, you can add an element at any position. Case 2, you can add an element at the beginning of the list, and that's why we input the number of the user, use create a new node in order to create a node using this number, and we call function add at the beginning so that we add this new node at the beginning of P first node. And we have already implemented add at beginning function. If the user clicks 3, and that's we will go to case 3, we add an element at the end of the list. All right, so we call add at end, and we use the new number that we input from user in order to create new node here, and this of course returns the pointer to the new node, and we pass it to add at the end. Case 4, if we want to remove an element at a position k, so we ask the user to input the position k. First, we make sure that this position is not greater than the number of elements in the list, because if it's greater than the number of elements in the list, then it doesn't exist. So if position is greater than the number of elements in the list, which is present at P first node dot number, and if it's not equal to 0, we have to check also that it's not equal to 0, because we cannot remove the element 0 in the linked list, then we only remove when these two options are not valid. Then we have to go to this else in order to remove node, P first node position. So we're removing the node from the linked list at position, and of course remove node, we have implemented it earlier. Remove an element at the beginning, okay, it will only say remove an element from the beginning, and it will remove this element without any input from the user, because it simply removes node 1. Okay, remove from the end, it actually calls function remove from end, which remove the item, the node, which is at the position listed in the node 0, where the number of elements exists, and we have implemented it earlier. Case 7, if you want to change an element value at the kth position, again we take the new number that you want to change it to this new number, and the position at which to change it, and then we have again to make sure that this number, okay, the position, okay, actually exists in my linked list. So we check that the position is not greater than the number stored in the first node, which is the number of elements in the linked list. If this position is greater than this number, so we don't do anything. Okay, we don't actually change the value because that's not valid. So we make sure that the position is not greater than this number. So if it's not greater than this number, we go to else, and that's where we call function change node value. We give it P first node, which is your linked list, the new number, and the position. Change the element at the beginning, we only take from the user the new number, so the new number to change it to it, okay? And we don't take the position because we're changing at the beginning, where the position is definitely 1. If the case 9, then what you want to do is change the element at the end. Similarly, we take only the number, and we call change at end. This is the linked list, and that's the new number to which to change the last value. And now this one prints all the elements, and this is the function print that we have implemented that takes only P first node, which is the pointer to the first element in the linked list, and actually iterates through all the items and prints the pointers and the values as we saw it. Case 11, display the value of an element at the kth position. We have actually done it in function display node. Again, we take the position from the user and we check that this position is not greater than the number of elements in the linked list through this if. If it's not greater than, then we go to the else, and that's where we call display node, and we give it, pass to it the linked list pointer and the position at which to display, at which the node to display exists. Finally, the default part of the switch, if none of the other options are there, okay, then we say invalid action, please try again. And of course, if he puts 12, then the while will exit. I will put you all this code. I'll make sure it's present in your in a Word file that I'm going to put in a Word file that I will put you on Moodle. Okay, so there will be a Word file with all those codes so that you can actually use them, copy paste them in order to create your file, run it, and show me screenshots of your run by sending it as an email. And again, make sure that the title is comp232, okay, linked lists, and please send it to me. And then there's going to be an assignment on linked lists from the lab, okay, and actually at the end of the Word file that I'm going to post like last time. Okay, encourage you all to stay interacting with me, and please, if you have any question, write it down in comments. You may subscribe to my channel so that you can get the videos that I post as soon as I do. And to make sure that all of you get notified, I also will notify you through Moodle. Any questions, you can always email me or write comments, and I'm ready to do a session that answers all your questions. Thank you, and until next time.